Assalamu alaikum. I'm Zain Sultana. Today our topic is playfair cipher. Playfair cipher was the first practical diagraph substitution cipher. The scheme was invented in 1854 by Charles Wheatstone but was named after Lord Playfair, who promoted the use of the cipher. In playfair cipher, unlike traditional cipher, we encrypt a pair of alphabets instead of a single alphabet. It was used for tactical purpose by British forces in the Second Boer War and in First World War, and for the same purpose by the Australians during World War II. This was because playfair is reasonably fast to use and requires no special requirements. Now we have some rules for our playfair cipher. We have rules for plaintext. If we have a plaintext which is software engineering, first we have to remove all space from our sentence or verse. We have to remove all space. Then if we have similar type of words together, that means repeated words together, then we have to put x between them for separate them. Then we have to make pair of them, divided them by 2. If we can find that we have odd number of pairs, then we have add x in the last with the last word. So we will find our plain text. Then we have rules for key. If our key is software security, then our first text will be remove all space. Then we have to remove our repeat letters. There have S, E, R, T 2 times. So we can put only one letters. So we have to remove S, E, R, T, which are double in here. So after that, our key is SOFTWARECUIY. Then we have to make a 5 by 5 matrix for our key. In this matrix, we have 25 boxes and we have to fill with our key first, which is SOFTWARECU. And we have to put I and J in the similar box. This is our rules. Then after putting Y, we have to put the rest of the alphabets there, but we make sure that all alphabets should be unique. There will be no repeated alphabet there. Then we have encrypt our playfair cipher. So for this we have our plain text and which is divided into pair, and we have our key and we have the 5 by 5 matrix for the key. In this situation, we have some rules. If our pair, which is SO, suppose, is in the same row, then we have to move one box right. And if our plain text are in the same column, we have to move one box below. And if it is rectangle, then we have to swap. Let's see an example. Our plain text is SO. Our first pair is SO. So we have to, this is in the same row, so we have to move one box right. So one box right is OF. So our encryption will be SO will OF. Then for FT, we have, this is also in the same row, so we have to move one box right, so which will be FTW. Then we have WA. WA, here is our W and here is A, and it make a box which is rectangle. So in this case, first we have to find out that which is our pair, which is W and A. For this, for W, this is our rectangle box, WA, and the box will be all the letters including first and second column. So for W, we have to take the second letters total box and the last alphabet of it, which is U. And for A, we have to take the box of W and we have to take the last letter, which is S. So for W, we take U, and for A, we take S. So this is our rules, and we take every letters, every pairs like this. And our encryption method was that, and our decryption method was similarly, but we have a little bit difference in our decryption process. In this process, if our plain text pair is in the same row, we have to move left, and if they are in the same column, we have to move our upper box. This is the difference between them. And now we have our code, which is our encryption code. For this, first we have to notice that our plaintext is validated. There should be only letters which should be allowed. We have to accepting only letters and removing all space, and also have to capitalizing it. In this section, we have to add X between the same letter, which are appearing one another. After that, we have to work with our key. From our key, we have to remove space and we have to capitalizing our key. And we have make a 5 by 5 matrix and fill the matrix with all the key alphabets, and the rest of the boxes should be replaced with other alphabets from our A to Z. Then we have to sure that only unique characters should actually in this key. And we have to keep I and J in the same box. After that, we have to make a matrix which will be 5 by 5 matrix. Then we have to find the index of an element in the key matrix. After that, we have to prepare our ciphertext for encryption. Now we can see our result that if we enter our plaintext software engineering and enter our key software security and select, we have to select I or J for our encryption. If I select I, then this will be our output for our plaintext software engineering. After that, we have this decryption code. In our decryption code, it is similarly with the encryption. First, we have to validate our ciphertext. Then we have to fill our keys with A to Z, and we should Remember that only unique characters remain in the actual key. We have to put I or J in the key, and then we have to place the 5 by 5 matrix the key. The function finds the index of an element in the key matrix. Then we have to prepare our plaintext for decryption. Now we can preparing our plaintext for decryption. After decryption, there will be a box which we can enter our ciphertext and we can enter our key. After that, we have to select I or J for decryption, and after that we will find our decrypted plaintext, and if we want we can remove the X between the similar words and we will find our actual plaintext. Thank you everyone.